Okay, this one says write a formula that describes this sequence. Okay, to make our life easier, I'm going to tell you what some formulas are for these. Okay, but our first job is to differentiate. We need to know if it's an arithmetic sequence or a geometric sequence. Okay, and to figure that out, we need to see how do we get from term to term. Remember, an arithmetic sequence has a constant difference between terms. I mean, I add or subtract the same thing to get from term to term. Okay, well, constant difference, again, means I should be able to take this number minus that one and get the same number as if I take this one minus that one, or this one minus that one. And in this case, if I take 6 minus 3, I get 3. If I take 9 minus 6, I get 3. 12 minus 9 is 3. So my constant difference in here is 3. So this is in fact an arithmetic sequence. Okay, now I'm going to make a little table over here to kind of help us see this. And this letter N and this letter A. Okay, well, N is the number of the term in the sequence, meaning like first term, second term, third term, whatever it is. And A is the value of the term. Okay, well, in this sequence right here, I've got 4 terms listed, so I need 4 boxes off to the side of this. And the number of the terms up here is simply 1, 2, 3, and 4, because I've got the first term, the second term, the third term, and the fourth term. Okay, and I know that for sure because it doesn't tell me there's any numbers before here. If it had a dot 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 here, then that might make things a little more complicated. The A is the value of the term, meaning the actual number here. So 3, the first term is 3, the second term is 6, the third term is 9, and the fourth term is 12. Okay? Well, an arithmetic sequence always follows the same formula. Okay? And how we write this is the value of a certain term, because remember, A means value, and N is the number of the term, so the value of a certain numbered term is this formula, F plus D times N minus 1. Okay, now here's what that means. Okay, this here stands for the value of a term. This here is the first term. This is the difference between terms. And this one right here is the number of the term. Okay? And here's how we write this. We say the value of any term is going to be equal to the first term in the sequence, and the first term is 3, plus the difference between the terms. The difference between the terms is also 3, times the number of the term minus 1. Okay? Now, we don't need to leave this like this, alright? We can go ahead and distribute this and simplify it as much as we can to make it easier on ourselves. So if I distributed this, again, I'd make this plus negative 1 to start with. So I get 3 plus 3n plus negative 3. And 3 and negative 3 cancel each other out. So that's the same as 3n. So this formula is the value of any term is 3 times the number of the term. Okay, meaning if I wanted to find the fourth term, I would take 3 times 4. If I wanted to find the sixth term, I would take 3 times 6. If I wanted to find the value of the 100th term, I'd take 3 times 100. Okay, so for example, the value of the first term should equal 3 times 1. So the value of the first term is 3. And that's what it was. Okay, the value of the second term should be 3 times 2. So the value of the second term should be 6, which is what it was. So if I wanted to find the value of the 100th term, I would take 3 times, what do you think? 100. And that value would be 300. So you can see how a formula would make things a lot easier to find the 100th term. If I was told to find the 100th term without finding a formula, I would have to find the 5th term by adding 3 and get 15. And then find the 6th term by adding 3 and get 18. And then add 3, and then add 3, and then add 3, all the way until I got to the 100th term, and it would take me forever. But this formula, okay, makes it really easy on me. Okay, so you will want to know this right here. This is very important for an arithmetic sequence. Okay, now notice what we did. We plugged our information into this formula, but then we simplified it as much as we can to make it look easier. Okay? And we got a nice easy term or formula here. Now let's go on and check out a geometric sequence. Now we're going to write a formula to describe this sequence. And again, our first job should be to determine arithmetic or geometric. Okay? I mean, is there a constant difference or a constant ratio? Well, in this one, if I take 3 minus 1, I get 2. If I take 9 minus 3, I get 6. So the difference isn't constant. So we need to find out, is the ratio the same? So we got 3 over 1. If I go 3 over 1. Then we would have 9 over 3. Well, that equals 3 over 1. And then we would have 27 over 9, which equals 3 over 1. So it's got a constant ratio of 3 over 1. So this is a geometric sequence. And I can make a little table here again to demonstrate how this looks. And we got my value, or sorry, my number of the term and my value of the term. Again, I got 4 terms. And the 4 terms are 1, 3, 9, and 27. And we need to figure out how to write a formula for this. Well, a geometric sequence is a little different than an arithmetic sequence. Alright, it always follows this formula. The value of a certain term is the first term times the constant ratio to this power. Okay, and this means the value of the term again. This means the first term. This is the constant ratio. Ratio. And this right here is the number of the term. Alright? So in this case, I'm going to make a formula using that information from this sequence that I've got. So the value of any term is equal to the first term, which is 1, times the constant ratio. Well, the constant ratio is 3 over 1, or just 3, to the n minus 1 power. Okay? Well, I can simplify that because I know that anything times 1 is itself. So I really don't need that 1 here in this case. So I can say that this sequence has a formula of 3 to the n minus 1 power. Meaning, I'm going to take my constant ratio, 3, and raise it to whatever term I'm looking at, minus 1, that power. So let's look at an example of this and how this works with this sequence. Okay, if I wanted to find the value of the first term in my sequence, I would take 3 to the 1 minus 1 power. Okay, because that's the value of the first term. So I plug in 1 for the number of the term. And that's 3 to the 0 power, which is 1. So that's saying the first term is 1, and that's exactly what it is. If I wanted to find the value of the second term, I would take 3 to the 2 minus 1 power, which is 3 to the first power, or 3. And again, the second term is 3, so it matches up. So if I wanted to find the value of, let's say, the fifth term, okay, the value of the fifth term would be 3 to the 5 minus 1 power, or 3 to the fourth power, which means 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So the fourth term would be 81. Or sorry, the fifth term would be 81. Okay? So again, formulas can make our life a lot easier instead of just trying to keep adding or multiplying to find terms. Okay, so this one is the answer for this. You'll want to make sure that you keep track of this information right here. It's very important. Alright? So use these formulas, this one for the geometric and the one for the arithmetic I gave you, as a guide for how to write a formula for an arithmetic or geometric sequence. Alright, best of luck on your homework.